Hi grade 11s, unfortunately I'm not in your class today, so you're going to be working through this lesson largely on your own. I've made you a short video to help get you started. We're on 5.3 logarithms, which is on page 21. A lot of this lesson is investigation led. So you're going to need to pause the video at times, and I will upload some of my answers to the investigations. That doesn't necessarily mean that I've included everything, but these would be my answers. Do try these investigations for yourself and then check the answers as opposed to just kind of copying down them as notes. So what you're investigating is summed up in this first investigation. So I'd encourage you to pause the video and work through the questions in the investigation and then restart it. Okay, hopefully you've had a go at all of these. So I want to talk through the first part of this first investigation because I think that gets you set up for the rest of the lesson. So we're starting off by considering this equation 2 to the power of x equals 8. So I'm sure you've tried, you found ways of describing the solution in words. I imagine it's something along the lines of, what do I need to raise 2 to the power of in order to get 8? That's what the solution is. So we need to raise 2 to the power of 3 to get 8. 2 cubed is 8. So there is an exact solution. Oops, it's not 8. It is 3. So I'm fairly confident that you will have done that. And I think that helps with the next question. Consider the exponential 2 to the power of x equals 5. So this once again means, what are we raising 2 to the power of in order to get 5 as our answer? But that's not so easy because we know 2 squared is 4 and we know 2 cubed is 8. So the answer must fall somewhere between x equals 2 and x equals 3. And trying to raise 2 to the power of 2.2 is not quite so straightforward. So we're not going to get an exact numerical solution. What we're going to look for first of all is how we can find an approximate solution. And of course that's to use our calculators. So we can solve that quite easily just by graphing 2 to the power of x and 5 and looking for our intersection. Okay, so we can get an approximate answer 2.32 using our calculator, and I'm hoping that's what you would expect. It should be a number between 2 and 3. We would expect it to be closer to 2 than 3 because 5 is closer to 4 than 8. So that makes sense. Okay, what about 2 to the power of x equals negative 2? So that's saying, what do I need to raise 2 to the power of in order to get negative 2? Well, of course, there isn't anything, is there? And hopefully, having graphed 2 to the power of x already, that should be clear, and it helps remind us, oh yeah, exponential equations have certain key features, one of which is this asymptote of y equals 0. So it's never going to reach 0, and it's certainly not going to get into the negatives. So C, there is no solution. But I think these questions are set up really nicely to kind of guide, like, what you do in A helps you understand with what to do in B and so on. Okay, so this is the really important one, D. Consider the equation a to the power of x equals b. And we're trying to solve for x. Can you describe the solution in words? So in words it is, what power must I raise a to in order to get b? I don't think my English is very good there. Maybe 2 what power would have been better. To what power must I raise a in order to get b? If you think back to the very first question, 2 to the power of x equals 8, that's what we were thinking, wasn't it? What power do I need to get 8? And this is where logarithms come in. So in general, the solution of that equation we've just been talking about is the logarithmic function x equals log base a of b. So that's how we say this. Oh, I've just drawn all over that. Try again. Log base A of B. I'm going to put that in quotations because that's what we say. Log base A, well, A was the base, X is the exponent. So base A, that does make sense. A and B have to be greater than 0 and A is not equal to 1. If A was 1, we'd be doing 1 to the power of something, that's always going to be 1. And we talked earlier that B and A are both greater than 0. So I probably just talked about all the things that it says in the notes here. A is called the base of the logarithm. Any positive number can be used as a base for logarithms. The only ones in our course are 10 and Euler's number E, which we talked about last lesson. It could be in other situations you want to use other bases. 2 is sometimes used. It could be in other courses that you do. You will end up using other bases, but for the MAIHL course, it's 10 and E. So there's some shorthand. And really, it's shorthand for just these two particular ones that we're going to use. Base 10, because it's the base system that we use for counting, we would write log base 10x as just log x. So on your calculator, you may have noticed that above the enter sign and below the delete sign, there is a button that says log. Okay, and that means base 10. The other one is with the base e. It's called the natural logarithm, and it's written lnx. Some people say lnx, lnx. I don't need to do that for x. Other people call it ln x, and that is the natural logarithm. So that's the shorthand for that. And you'll notice on your calculator that's next door to log. So log and ln are specific bases, base 10 and base e, and very helpfully they're the two that we deal with. So this is the whole idea of it, is that we have this relationship. If I am trying to solve this equation, 10 to the power of x equals c, what power do I need to raise 10 to in order to get c? We can rewrite it as a logarithm. So x equals log c. For example, if I was trying to solve the equation 10x equals 330, I'd rewrite it and I'd say x equals log 330. And I'd go to my calculator, log 330, and there it is. If I raise 10 to the power of this number, I should get close to 330. Okay? Equally, same idea if we're talking about the base e, but I'd use ln. Okay, this relationship is in your formula guide. We're in the topic 1 because we're dealing with a number algebra topic, and it's in the SL section. So here it is, SL 1.5, and you can see this is the equation we've been talking about, and this is the equivalent equation. Obviously, you might have instances where you want to move from the right to the left. Maybe maybe the thing you're trying to solve is either A or B, and you want to rewrite it as the left-hand equation. Okay, so you can obviously calculate these quite easily, but we are going to do a few of them together. So we're going to rewrite them in exponential form, so taking them out of the log form. So, in fact, you know what, I'm just going to copy down how it's written here. A to the power of x equals b. Then they write this as, they start with the x. Okay, x equals log base a of b. So, here's my equation. I've got x equals ln, so that is log base e. Log base e. So if I want to go from the right hand to the left hand, my base is e, so I'm going to write it e to the power of x, and my b term is this e to the power of 5. And hopefully what we can see is that x must equal 5. Okay. So really what's happened here is we can think of the ln and the e as cancelling out there. They're inverse operations. So x equals 5, that makes sense. Let's do one more of these. Let's do number 4. So moving from the right-hand side equation to the left, my base now is 10 because it says log, that means base 10. So I'd rewrite it as 10 to the power of x equals 1,000. What do we need to raise x to? Sorry, what do we need to raise 10 to in order to get 1,000? X equals 3. Of course, you could just do this on your calculator. You could just do log 1,000 equals 3. Okay, there's a question down the bottom that I would like you to think about. We'll talk about it next lesson. Why do you think some graphs are drawn with a logarithmic scale? Often it's just on one of the axes, on the y-axis. Can you think of an instance why, like what kind of data you might want to use that for and why you might do that? Folks, there's some general rules of logarithms which are on the next, which you're going to investigate on the next page. So work through the investigations and try to think about what are the kind of the key rules that I can take away from here. In particular, questions 4 and 5 are some, I think, and 6 actually, yeah. There are some, they're called log laws. Laws of logarithms, let's use the correct term. So you're going to do some investigating to try and determine what those laws are. All right, that's everything that I'm going to do on video. I will go through and I'll fill in all the blanks and you can check your answers with that. And then there's a few questions to have a go at for homework. So the key idea then is being able to move between these two different forms. We've got a way of writing an exponential equation and a logarithmic equation, and that there is an equivalency between them. We can move either way from exponential to logarithmic or vice versa. We have two bases that we deal with, base 10 and base e, and that there are some laws of logs that will come up on the next pages. In our course, the emphasis is not so much on those because we can often use our calculators to avoid needing to use the laws of logs, but they can, people can always write questions that force you into using them. So they are worth working through. The good thing to know is that all of the laws can be found in your formula guide in the higher level section. So try not peek a look before you have a go at the investigation, but they are all there. They're not ones we need to learn. So that's good news. Okay, best of luck everyone.